In this tutorial, we're going to see some other problem related to mass balance, but another system. It's activated sludge tank. So we are going to perform a mass balance for this for activated sludge tank. I'm going to read the problem first, and then we will solve it one by one, or at least try to understand what the problem is about. So activated sludge tank is receiving 6 into 10 to the power of 6 liters per day of wastewater. So this is something like a input stream which is going into activated sludge tank, and this tank contains dissolved organic concentration. So this will be your substrate of 300 milligrams per liter. So first I will read the problem, and then I will explain what is activated sludge process. Probably most of you would know this thing by this, probably might have learned this in other modules. And anyway, I will explain it briefly what activated sludge tank is. So that contains a substrate concentration of 300 milligrams per liter and a microorganism concentration x0 of 0 milligrams per liter. In the problem I already gave some notation. So S0 means initial substrate concentration, x0 means initial microbial concentration, and there is a recycle FR, and a waste sludge flows are X percentage and 2 percentage of your F0 respectively. F0 is your feed stream that goes into activated sludge tank, and recycle and waste sludge, we will see soon what is that, what this mean. I will explain to you when I'm going to explain activated sludge tank. And organic concentration in the effluent. So I gave some notation, which organic concentration means your substrate, and waste sludge SW is 20 milligrams per liter. And then maybe better I will try to explain what's an activated sludge tank. So activated sludge tank is this is like a continuous stirred tank. So something that goes in, normally it's pollutants, organic compounds, organic pollutants. So this is your wastewater that contains a lot of organic pollutants. It goes inside, and we have some microorganisms inside the tank. So they all consume your substrate, and then they convert them into products, and that can be easily digested by your live cells, and then they take some of the product outside. So something that goes in, something that comes out. So whatever that comes out, that contains almost no substrate, but they contain lot of microorganisms. Yeah, so some substrate goes inside, and there you already have some microorganisms inside, and then you take them out. So this flow rate in and flow rate out should have some meaning, and then the output will be connected to a sedimentation tank. So what happens in this tank? It's like your live cells will get settled, and then so due to gravity, we call it as a gravitational sedimentation tank, or sometimes they call it as thickener, because it's thickening the solution, so that you get a very dense solid in the bottom and more water on the top, and then you remove the effluent on the top. So this is activated sludge unit is something that we use to treat large quantities of wastewater, domestic wastewater. So you take your effluent here, and then you take the concentrated biomass from the tank, and you dispose them as waste, and you take some part of, say, you put a T joint, and then you divide them into two different streams. So one stream goes like a waste, you dispose them, and then another stream you recycle them, and then pump them into your activated sludge tank. So you can call it as activated sludge. One reason is like the microorganisms which is inside this tank, they are growing at the exponential phase, which mean at the maximum rate. So that's another reason they call it as activated sludge. So this is the sludge which comes down. It contains very rich concentration of microorganism, because they are settled down, so they should have very high concentration of microorganism, and you are returning them. So this recycle stream, we call this as a recycle stream, and then just FR. Give me a second, let me change the my pen refill. So we call this as a recycle stream. So this one is FR. So FR means flow rate of the recycle stream. And why do we need to recycle here? Because normally wastewater, we have to treat really a large quantity of wastewater every day. So for that we need a very big tank, and obviously we cannot construct a massive tank. So what we do, is like so we pump a large quantity of wastewater in the input stream. So we increase the flow rate, but sometimes when you increase the flow rate to beyond some extent, so it will it will wipe away, or how can we say it, it will sweep all the microorganisms. So you all know in the microbial kinetics, microorganisms, they eat your substrate and then convert into your products. But if you pump your wastewater so fast, it can take all your microorganisms, and then all your microorganisms will come in the effluent, so before converting your substrate into product. So normally we call them as a washout of your microorganisms. So if you want to operate your reactor at very high flow rate, imagine you pump your input stream at a massive flow rate. Well, at the same time, if you want to maintain some microbial concentration inside the reactor, and if you want to avoid washout of your microorganisms to happen, then you must recycle some part of your microorganisms from the sedimentation tank, and then you can put it back into the activated sludge unit. So this is the main reason we recycle, but we will study this in detail in the next year, CG 4017. But for this module, all you need to know is how the activated sludge unit works and what's the principle. So activated sludge unit contains one main tank where your microbial reaction is happening, where your substrates are getting consumed, and where your microorganisms are generated, because your microorganisms are replicating. And then you take that microorganisms outside, and then it goes to a sedimentation tank, so that you can concentrate your microbial concentration at the bottom of your sedimentation tank, and then you recycle a part of that stream from the sedimentation tank back into your main tank, where the biochemical reaction is happening, and then you remove the rest of your cells, or the sludge as waste. And you also take the clear solution, which is free of organic pollutants, as we call them as effluent. So we take them from the top of your sedimentation tank. At the top it should be free of your, or at least your cell concentration will be very less, and there should be few more assumption. Your microbial reaction happens only in the sedimentation tank, and nothing happens once it leaves the tank. So these are few things that you should remember. That's the principle of activated sludge unit. So let's go back to the problem again. So we are going to pump 6 into, let's change the color. So we are going to pump 6 into 10 to the power of 6 liters per day of wastewater. That's your feed stream F0, and it contains a substrate concentration of 300 milligrams per liter. So we have to convert them into, we have to break them, and we have to consume this substrate and convert them into products, which is more microorganisms. And your feed stream contains 0 milligrams per liter of microorganisms. And I also gave some value recycle FR, which is your recycle flow rate of your recycle stream, and your waste sludge, flow rate of your waste sludge flows at a rate of X percentage, which means we don't know the flow rate of your recycle stream, but we know the flow rate of your sludge, waste sludge, which is 2 percentage of your feed stream respectively. And then organic concentration in the effluent. So if we go back here, effluent is somewhere here. So organic concentration of effluent in the effluent and waste sludge is 20 milligrams per liter. So we know what's the substrate concentration in the waste sludge and what the substrate concentration in the effluent. And microorganism concentration in the waste sludge is 5000 milligrams per liter. So we know the concentration of the microorganisms in the waste sludge, which is 5000 milligrams per liter. So these are the question. You should draw a flow sheet for the whole process. I already explained what's an activated sludge process, so you can easily draw that. The flow process is like all you need is to make a tank, and then followed by a sedimentation tank, and some input stream goes in, some effluent comes out, and some recycle stream which goes back to your sedimentation tank, and another stream you are going to dispose your sludge. We can call them as a waste stream or a waste sludge stream. So we have to draw the flow sheet and you have to give some notations. So that's how we have to deal the mass balance. So draw a flow sheet for the whole process and give appropriate notations for each of the stream, and then assign proper notations for all the components. So there are few components involved. So one is your substrate, another is your microorganisms. So you have two components in this system, and try to write units. So don't mention like 0 or 10. It should be 10 milligrams per liter, 0 milligrams per liter. Yeah? And then write a general mass balance expression for the above process, and assume process is at steady state. So steady state means like your microbial concentration and your substrate concentration in the tank is going to be constant. And then we go to 3 is perform flow balance. You have to perform your flow balance, like how much mass goes in, how much mass comes out, and then you also need to perform a flow balance for individual components. If there are some parameters missing, then you can calculate them, and then calculate the mass of substrate consumed. So you all know how microbial reaction works. Yeah, so just to think this activated sludge tank as a microbial reactor, which is true. So we are pumping something inside at some constant flow rate that has some substrate, and this tank already contains microorganisms, which means this tank is going to take the substrate and convert them into more microorganisms. So which means something will be consumed, and the thing which is getting consumed is your substrate, and the component which is going to increase, or we can call it as something will be generated in the tank. So that will be your microorganisms. You all know how to write microbial reactions, like you have some substrate, microorganisms take them, and then it produce more microorganisms, which means microorganisms will be generated, and then your substrate will be consumed. So what's the question is like, calculate the mass of substrate consumed, that you need to calculate based on the information you have, and then you have to calculate mass of microorganisms generated inside the reactor. So how much how much microorganisms you generate, and then how much substrate you consume, and then calculate mass of substrate in the effluent. So what's the concentration of your substrate and microorganisms in the effluent, which is here. So we need to calculate the mass of your substrate and then mass of your microorganisms, and also we have to calculate the mass of substrate in the recycle stream as well. So you have to calculate your substrate in the recycle stream, in the effluent, and waste and recycle stream. So you have to calculate mass of substrate and microorganisms in the effluent, mass of substrate and microorganisms in the waste, and mass of substrate and microorganisms in the recycle stream. So these are the things that you have to calculate. So I think we can. So the first thing is I ask you to draw a flow diagram. It's already drawn here. And then give me a second.